Hi everyone, in this video I just wanted to quickly go over how to find the initial values of sine, cos, and tan function. We're not going to be going over how to find the rules. I did go over what the graphs look like, so if you want to visualize them as you're finding the initial values. But even if you don't know what the graph looks like, you can still find the initial value with a unit circle, the calculator, and obviously knowing that the initial value is the value for y when x is 0. Okay, so we're going to be finding the value for y is when x is 0. Okay, so we're going to start with sine. No, actually, we'll start with cosine. Okay, so here's my example. They're very similar. If I asked you to find the initial value of, so this function is transformed, but in terms of finding the initial value, we're not graphing it. Okay, so we don't really have to work with the parameters. So how do we find the initial value? Just like any other function, we replace the value of x with 0. Okay, so I'll do it step by step. -2 plus 5. We have to figure out with what the angle is here, right? So this is cosine. Whatever is in this bracket becomes an angle. So this is -4 cosine of -2 pi over 3 plus 5. Now, I want to show you an exact value. Okay, so technically, yes, you can use your calculator in radians. Okay, so we're always going to be using radians. But I want to show you an exact value. So what we need to do now is we need to figure this out. We need to evaluate this, right? So how do we get rid of this? We need to evaluate it. The first issue here, so I'm just going to go off to the side here, is that the angle is negative. So because the angle is negative, I'm trying to avoid using a calculator as much as possible. So in one of the earlier videos, I showed you how to go from a negative angle to a positive angle. The coterminal. All you need to do is add 2 pi. Okay, so I'm going to add 2 pi, but I want to add 2 pi with a radius of, not a radius, a denominator of 3, which is like 6 pi. So this is actually the same as 4 pi over 3. So the reason I did this, like I said, I'm trying to avoid using a calculator. So I want to find, so the cosine of -2 pi over 3 is the same as the cosine of 4 pi over 3. So 4 pi over 3 is somewhere here, right? That's 1, 2, 3, wait, 1, 2, 3, 4, 5, and 6, yeah. So this would be 4 pi over 3. So I want the cosine. The cosine of 4 pi over 3 is -1/2 root 3 over 2. So -1/2. Okay, so I hope you got that. I want to use the unit circle. I didn't want to use my calculator. I don't have this on my unit circle. I changed it into a positive value. It's the same, they're equivalent. And then I went to my unit circle and I got the cosine. So now all of this gets replaced with -1/2. 2 plus 5, the initial value is 7. Okay, so let's do the initial value of sine. So that's very similar. Okay, initial value of sine. So I have my function. Here. It doesn't always turn into a negative value. Okay, that was just one example. So the initial value, again, oh, I did it in one step. I don't want to do that right away. I wanted to just show you the function first. I wanted to show you the function. So this is a transformed function. Okay, remember if it's sine or cosine, it's a sinusoidal function. But we're just, remember you can always use Desmos. Okay, if you want to see, you can go on Desmos and see exactly what this looks like. You can graph that in there. But for the initial value, we don't need the graph. We just need we need to know how to find the property. So that's like in any function. So this, okay, so pi over 2 times 3. The only difference, obviously, is that there is this trigonometric component. So you need to evaluate this. You need to evaluate that. Okay? So we go to the unit circle. 3 pi over 2 is right here, right? That's why it should be memorized. Next year, you don't know. Some professors don't allow calculators. 3 pi over 2 is 0, negative 1. The sign is the second one, and that is equal to negative 1. Negative 3 times negative 1 is 3. 3 minus 5 is negative 2. Okay, so the initial value of this function is negative 2. And don't forget, if you want to see what it looks like, you can graph it on Desmos. Okay, and then our third example, you can do a lot more examples on MHS. The assignments this week will have part of it initial values, part of it finding the zeros. That'll be in the next video. So the last one is the initial value of the tan function. So what do we have here? We have a negative square root of 3, the tan of x plus pi over 3 minus 5. Okay, so it's the same thing. Replace 0. Simplify. Remember, at some point you need to think about your unit circle or use a calculator, but I'm trying to avoid using a calculator. So there it is. We have to figure out what this is. Okay, so I'm just gonna pretend that I had my unit circle here. Unit circle, pi over 3. This is pi over 6, pi over 4, pi over 3. Pi over 3 is 1/2 root 3 over 2. So the tan is sine. The tan of pi over 3 is sine over cosine. So this actually cancels and it's equal to root 3. Okay, which probably explains why there's a root 3 in the as a coefficient there. So it'll simplify. So this becomes the square root of 3 minus 5. The square root of 3 times the square root of 3 is 3, but negative. So the initial value is negative 8. Okay, so initial value is easier. Try to do more examples on MHS. And that's it for initial values.